said, my name is Andrea Love. I'm a principal and the director of building science at Payette, which is an architecture firm located in Boston. We're one office, really focused on the research and healthcare market. And as a building scientist, my role in the firm is to really bring an integration of performance into the design process so that as we're looking at different design decisions, we can understand how they impact things like comfort and glare, in terms of the occupant experience, daylight for the quality of space, peak loads because that'll impact your capital costs, as well as the energy usage, which impacts your ongoing operations. The other part of my role is that I lead our internal research efforts, so there's a lot of problems that we'll see in the design process that we often can't really solve kind of in that quick moving process that happens during design, but we see a benefit in kind of stepping outside of the design process to dig into and understand a little bit more. So things like thermal bridging and how we can improve those details to increase performance or other issues that we might see. So as you might be able to tell, I'm a bit of a nerd, and so I'm going to try my best not to have too many graphs. I promised my marketing people that we would have things other than graphs. But I was going to talk about patient-centered design, which I think is really the future of healthcare and where healthcare is going. And in particular related to architectural design and what I'm interested in is kind of this thermal comfort. And I really think we're going to achieve this through an integrated design process where we think about everything holistically and not kind of individualized. And so to just kind of give everyone, I know there's a number of engineers in the room or people who have engineering backgrounds, just to make sure everyone's kind of up to speed on the basics of thermal comfort. There's 6 factors that influence thermal comfort, 2 of which are controlled by the occupant, sort of what they're doing and what they're wearing. I usually can't control that, at least as a designer, but I'm hoping maybe someday. And the other are really controlled by the building design, so the humidity, the air temperature, the radiant temperature, and the airspeed is the one I had mentioned. So one of the challenges with the model that we use for thermal comfort is it came out of a researcher, Fanger, in Kansas in the 60s, and it was really based on a pretty homogeneous group of people and homogeneous way of thinking about how people worked. It was really with an office mentality in mind, wearing 3-piece suits, which was the standard, there we go, which was the standard in the 60s, and primarily men and sort of younger men. And so today we have things like the 2018 office Snuggie, and there's a lot of challenges for different populations, and particularly related to healthcare. One of the challenges I think we have is that we don't really have any good research on how thermal comfort impacts populations that may have suppressed immune systems or other things that may impact their abilities to be comfortable. So one of the things, so I was particularly interested in how thermal comfort related to healthcare, and so we did a research project trying to understand this a little bit better. And one of the challenges that healthcare also faces is you have very diverse populations with diverse needs. So if you kind of just use that standard model, not even taking into account that we can't really factor other things like illnesses, where patients may be comfortable actually doesn't even overlap with a lot of your clinicians because they're wearing more clothes, they tend to be moving around. And so this is a pretty challenging environment, as I'm sure many of you know, to try to accomplish thermal comfort. And so we went out and we started measuring a lot of different spaces to start to understand what are we actually operating at? Are people comfortable? Are they not? How do they kind of actually match with this model? And what are some of the things that we're observing where things deviate? Interestingly, one of the things that we noticed in almost every space that we went to where things deviated from the acceptable norm of comfort was actually in the airspeed. So where we placed the diffusers, because we have such large air volumes, that it often was creating perceptible drafts that were kind of further exacerbating these problems of comfort. And so today, because comfort's sort of a large issue all over the hospital, I'm going to talk specifically about the window box unit, sort of the window in a patient room, which is their connection to the exterior, it's the family area, and sort of where I think we can encapsulate a lot of the issues that we need to think about in design as it relates to thermal comfort. So one of the first things, at least in the Northeast, I'm in Boston, that we have to deal with is it's cold. And so because we have a large window there, there's 2 factors that impact being cold there. The first is it's a cold surface, and so we have radiant discomfort that happens. But we also have downdraft, where warm air will hit that glass surface, it will fall, and we'll feel a perceptible draft. So we usually counterbalance this by putting in perimeter heat. But the perimeter heat has the challenge of it takes up space. It costs money to install, it costs money to maintain, and creates a number of challenges. So what we found is if we can adjust our design to make sure that we're always within that threshold of comfort by adjusting the size of the window, going towards things like triple glazing, even though triple glazing is often viewed as a premium, if we can look at it as the ability to eliminate the perimeter heat while still maintaining comfort, then it's actually significantly cheaper than installing that system, is in addition to reducing energy and maintenance costs and capital cost. And so we've been starting to look at this for a number of different patient rooms that are currently under design. We've looked at it both through modeling and also through mock-up to make sure that we're achieving the same level of comfort that we would otherwise achieve with that system. So we now have this passive system that can achieve comfort as opposed to an active system. And on the flip side, in the summer, when we look at a patient room in the window box, when we were looking at it from an energy standpoint, one of the biggest things we could do, and this was a project in Boston, so not necessarily a cooling-dominated climate like some of you may be from, but still quite a bit of cooling energy even in Boston. The biggest thing that we could do was to go towards a chilled beam system to reduce the energy usage. So what we had to do to make sure that we integrated this into our design is to look at, there's a certain kind of peak load capacity that a chilled beam can handle, to make sure that we can stay within that envelope, there's sort of that maximum capacity. And the solar heat gain is really the biggest part that influences that. So trying to make sure back and forth iteratively, there was probably hundreds of these models that we ran to make sure that we're staying within that comfort threshold so that we can create a more comfortable environment, but also kind of achieve that system that will create a more comfortable and energy efficient system. We also need to create a visually comfortable environment, right? Because if we want to have patients to have that connection to the exterior, but if there's a lot of glare and other problems, and the shades are always down, then you've lost that benefit. And so from that connection to the exterior, one of the things we've also become interested in is sort of getting natural ventilation in patient rooms. It's something that obviously is not very common, and actually for a while wasn't even allowed under the FGI guidelines, but recently has been allowed. And so what we've been trying to do is to understand, well, what are the barriers to getting this into a project so that we can understand them better, and how would that actually impact design? How would we design a space to meet these requirements, still maintain the air change rates that are required, but also allow patients to provide that connection? And there was an interesting article just about a month ago in the New York Times by a doctor who was she was a hospice care doctor, and about the number one thing that her patients always want is the ability to open the window, to hear the birds, to feel the breeze. And there's a comfort impact, not just the sort of psychological benefit of the connection to the exterior, but there's a comfort benefit in that in ASHRAE, when they've done their research on thermal comfort, they have a new model called the adaptive comfort model. And what they found is when occupants have the ability to open and close their own window, they're actually willing to accept a larger temperature range because now I can control it. And so giving people that ability to control, it's the same way we put in dummy thermostats. I also think dummy thermostats are actually a really good way to start to understand whether people are hot or cold. I remember recently being in it was an infusion space where they had about 6 different dummy thermostats, and when you walked around, there was 4 that were set at 85, 1 at 75, and 1 at 65. So most of the people, I think, were cold, but there was one person that was clearly hot. And so we did a survey talking to, it was sent out people all over the country to try to understand, well, what are the barriers? What are the top concerns that you would have of trying to get natural ventilation in a patient environment? And the interesting thing, one of the things that I thought was most interesting, and I'm happy to talk more about some of the things that we found, and I thought this group might find interesting, was the sort of disconnect of what everybody thought from a sort of general way. So the architects were all basically like, yeah, this is great, why aren't we doing this? About 85% thought we should have operable window in patient rooms. The engineers were sort of on the fence, about 65% thought it made sense. And the facilities actually were sort of split. There was about 50% that thought we should have operable windows in the patient room, and then 40% that thought absolutely no way, there should be no operable windows anywhere in the hospital. And so I thought it was just kind of interesting, this sort of the different perceptions that we all come at with issues like this. So I was going to spend the remainder of my time kind of talking a little bit about one example of how we try to bring this all together into an integrated design. So this is a project that we were lucky enough to win a design competition for. It's not a US project, it's in China, so we have a little different cultural mindset on some of the things that we might be able to do. But we really won this competition based on our thoughts about this window box and how people could use it and occupy it and an amenity that it might provide in the patient room. And so one of the first things that we set out to do was to try to incorporate this natural ventilation. In China, they follow the UK regulations, which are much more lenient and much more common to have natural ventilation, unlike the US. And so it sort of started out with the mindset that there would be natural ventilation, so there wasn't as many barriers to that. It was much more commonplace. And looking at different ways that we can iterate and improve the design to really get it to the point where it's actually most of the time able to operate in a sort of naturally ventilated mode while maintaining the the amount of air exchange that are required and the temperature that's needed. And so really trying to understand not just how it was going to perform, but the quality of the space that would be created. Would it be comfortable? And so we did a number of different iterations, starting to look at things like glare and how we could minimize that to make sure that people would be comfortable. Daylight, so we wanted to make sure that the patients had sufficient daylight to still get that connection. As well as views, there was a mountain that was nearby. So we looked at kind of vectors to make sure that those were maintained to maximize those views. And so what we ended up doing was actually canting this window box, which started off as kind of a uniform square around the window, a little bit to really to make sure that we minimized our disruption of the views while maximizing kind of the performance aspects. As many facilities people may be thinking at this point, our client was like, these seem expensive. And so we said, well, yes, but there's a lot of performance benefits that we can see, and I think we can justify why it makes sense to invest in them and actually how it can maybe not be a premium. And so we went back to the drawing board, and what we did was we said, okay, we have this big shroud that's wrapping all the way around, but really we only need it in a certain part of the window because the sun really only comes from, part of the sky. It doesn't come from every direction. And so what we did was we mapped out that kind of shading benefit of where we were getting the most benefit from the shade. And then we started to tailor it and cut the shades to match that. So that instead of having this kind of big shade, it was really a tailored amount. We also started to mock it up to try to understand its impact on the occupant experience, their views, their comfort. So how does this window open to get this natural ventilation? Where should this is a mock-up in our office that we did where you can start to adjust that kind of intermediary rail in the window to understand if someone was laying down versus sitting, where you can get it, where it would optimally be to maintain those views. And what ended up happening was when we kind of went back and re-looked at it was we were able to decrease the material by about 1/3 while maintaining the same performance in terms of the reduction in the HVAC system sizing, as well as the same comfort so that we could increase the comfort sitting in that window box by about 2 hours a day. And so we really think this kind of integration of thinking about everything together can really yield a building and a project that can achieve a lot more in terms of occupant design, making it something that is that's integrated together and to really improve their experience, improve their connections to exterior, a more comfortable space that we really think is the future of where healthcare needs to be today. Thank you.